Welcome back to uh, chapter 5 or chapter 10, section 5 for Math 121. Finally, we're going to look at volume and surface area. So our goals for this section are to look at the volume and compute volumes of three-dimensional figures and then solve applied problems. And then compute the surface area of a three-dimensional figure as well. Okay. So as we talked about earlier in the unit, volumes are how much stuff is inside. We talked about a cubic unit. And before we were counting them individually, now we're going to be able to calculate what they are. So here's some simple examples. The volume of a cube of a rectangular solid, like I think of like a box, that's length times width times height. And if we calculate those, then that means that's how many of these cubic units we can stack in there. If you taught elementary, or if you're familiar with elementary, or if we're better at elementary kids, usually there's like green cubic centimeters that we use for place value and doing things like this. You can actually put a bunch of those in a box, and if you cut them all up and counted them all, these green centimeters just like this, right? That would tell you the volume in cubic centimeters of the box, which you could also find by multiplying and measuring how many centimeters this way, how many centimeters this way, and then how many centimeters that way. That product would give you then the total volume. If it's a cube, L, W, and S, I'm sorry, H, L, and W are all the same. We call it S side S. And so we get the volume of a cube is just S cubed. All right, here's an example. You are about to begin at work on a swimming pool. The first step is to dig a hole that is 90 feet long, 60 feet wide, and 6 feet deep. That's a lot of digging. You will use a truck that can carry a 10 cubic yard of dirt and charges $35 per load. How much will it cost you to have all the dirt hauled away? All right, so we got to figure out what this volume is. So 90 times 60 times 6 is going to give us a relationship in yards. Oh, well, we can convert each yard individually. So that's what they're doing here. So 60 yards or 60 feet is 20 yards, 6 feet is 2 yards, and 90 feet is 30 yards. Using again that relationship we talked about in, I think it was in section 10.1. Okay, and so converting each of these to yards, and why are we doing that, you might ask, is because it was talking about it will remove 10 cubic yards of dirt so we need to make sure we're comparing the same units. They don't talk about measuring or hauling like cubic feet. All right, so converting these then to yards, we can find then the volume of the dirt. So 30 times 20 times 2 gives us 1,200 cubic yards. And then the number of truckloads. Well, if it takes 35, if it does 10 cubic yards of dirt at a time, okay, then how many, we need to know how many truckloads there is in this. So we take the 1,200 divided by 10. That's going to give us then a total of 120 trips. And then that number of trips is going to be needed multiplied by $35 per trip. So 120 times 35 is going to cost us a total of $4,200 then to remove the dirt based on this relationship. All right, let's look at one more. Using the formula for a pyramid's volume, the Transamerica building in San Francisco is a pyramid with a small square base. No, sorry, with a square base. It is 256 meters tall, and each side of the square base is 52 meters. So this is 52 meters here on a side, and its total height is 256 meters tall. By the way, if you want to know how many feet, 256 meters, well, there's roughly, really roughly, 1 meter is 3 feet. It's a little bit more, but just really roughly. And so if we multiply this 256 by 3, well, 256 is roughly 250. And we're going to multiply that by 3. So that's, well, by 2 would be 500, so by 3 it'd be 70. So it's roughly equal to 750 feet. It's roughly So it'd be a little bit more than that. So it's probably 800 feet tall is the building height. I guess they kind of give it a measurement. All right. So we want to know what its volume is. Well, we're given that the volume of this is 1/3 the area of the base times the height. So the area of the base is 52 times 52 because it's a square base, which gives us an area of 2,704 square meters. And then multiplying it by the height and then dividing it by 3, yet the total volume is 230,742 cubic meters. That's a very big volume. Okay. All right, the volume of a right cylinder. So this is literally, if you're old enough to remember CDs, it's just like a stack of CDs where there's no hole in the middle. But cylinders are just the area of the cross section multiplied by the height by how many there are. Okay, so the area of this base is pi r squared. The radius in their situation has a diameter of 20, so that's the distance all the way across is 20. So the radius would be half that. Okay, so the radius is 10. So that's where the 10 yards comes from. And then the area is pi times 10 squared. So 10 squared is 100 times 9, which is the height. So many yards tall it is. So we have 900. 100 times 9 is 900 cubic yards. If we take pi to be 3.14, you roughly get 28.27 cubic yards. All right. Volumes of a cone and a sphere. The volume of a right circular cone that has a height r and a radius h is given by the formula V equals 1/3 pi r squared. Again, it's the area of the base times its height, but because the heights are being kind of like truncated by this line, how much it affects the volume overall, it ends up reducing the volume by 2/3, which is why we have 1/3 left over. Okay, and then the volume of a sphere is going to be given by this relationship, 4/3 pi r cubed. This is like the volume of a ball or like a basketball or something. Okay, so applying the volume formulas, here we have an ice cream cone with if we assume that's a sphere, it has a volume of 4/3 pi r cubed, but since the radius is 1, 1 cubed is 1, so it's 4/3 pi. We'll assume that the volume of the sphere is underneath that. And then we want to know how much, if the volume of this ice cream cone, if it fills this, will it overflow? So this is very much like the one that we did earlier. This is going to be the volume of the cone is going to be pi r squared times 1/3 times the height. And we're going to compare that to the volume of 4/3 pi r cubed, the volume there. Okay, so the volume of the cone, its radius, its height, so it's 5 inches cubed. And then the volume of the sphere is 4 inches cubed. And so it's big enough that the ice cream will melt inside the cone and not overflow. All right, finally, surface area. Surface area is the amount of stuff on the outside. So think of like if you're doing gift wrapping, right? It would be the amount of wrapping paper you need to enclose the volume or to wrap the gift. So for a cube, you have the same area. So if you have a cube like, or a rectangle like this, there are 1, 2, 3, 4, 5, 6 sides to any rectangular prism. And so for the special case of a cube, in that case, all the sides are the same. And so you just multiply the area of one side and multiply it by 6. But for the area of a rectangular prism, you have an area here. It's the same as this area. So that's going to be 2 of those. And you're going to have 2 of these areas. And then you're going to have the top and the bottom, which will also be the same, which is where this relationship comes from. And then the right cylinder, I don't know if you can see it here, if it makes sense to you, but you have the area of the top and bottom of the can, which is the 2 pi r squared. That's the 2 circles. And then the area of this sheet. So if you ever take a sheet of paper and wrap it around, so this is a cylinder, so the thing of paper. What you're doing is if you unroll it like that, so that was one full revolution. This distance here, which was the result of a circle, right? So that's the distance around. That's the circumference of this circle. And what is that length? Well, that length becomes then the corresponding distance along this one side. So its height here is the h that you see right here. And then this 2 pi r, that's the circumference part of the circle. That's the base. And so this area is just base times height, but the base comes from the result of wrapping or unwrapping, I guess, that particular circle. All right. So hopefully that makes sense. And then in this last example here, we want to know, find the surface area of this rectangular solid. So there are 3 areas that you need to find. The area of this side here, their area of the top, and then the area of this side. Okay, and then we add all this together, multiply them by 2. So that's what we're doing here. So this is one area here. It's 8 times 5. 8 times 5, that's the area of the top. And then 8 times 3. Okay, so 8 times 3, that's the area of this side right here on the front. And then also on the back side over here, if you can see it. And then this area, 5 times 3, that's the area of this side right there. So that's 5 times 3. So that's the area of those. Okay, so those are the 3 areas that I need to find. And then you multiply them all by 2 and then add them together. I personally would factor out that they all share a 2. And so I would do length times width plus length times height plus width times height. It just saves you from multiplying all these by 2, right? So 8 times 5 is 40. Multiply by 2, you get 80. But I would just add them all together first and then multiply that result by 2. It just saves me time. Okay. All right. I hope that was helpful, and I will see you in the next video.